Hello, and welcome to Fan Request Friday here on Answer Everywhere. Today we're taking a look at the Brave browser source code. We've looked previously at the source code for the Chromium browser on which Brave is based, and now we're going to dig into what Brave is up to, how they modify it, what things are different, that sort of stuff. I wanted to apologize for getting a late start. And remind folks that the maybe for the next few weeks the schedule, the timing on the schedule is probably not going to be super accurate. I'm working on figuring that out properly, but it's going to take a little bit, I think, because as some people know, some people may not know, I have a tiny baby. And so some mornings are different than others. And so there may the schedule's a little bit wiggly. There's a cloud around the start times for now, a probability cloud. And I'll try to narrow down so that I'm better at starting on time. For a while nobody was really watching the live stream. So it's a new thing for me that people are watching live. So just want to let people know that I'll try to do better, and I thank you for your patience. Okay, so here we are. I'm going to jump right into the Brave GitHub repo. I had opened like the Brave token white paper, and I'm not sure. This is the first kind of cryptocurrency adjacent or related thing that I've looked at. I'm not sure how I want to handle them in general. The nice thing about a lot of cryptocurrency related projects is they come with what are called white papers in the crypto world, which is more or less similar to a design document. They tell you how the thing is supposed to work, what the design is, and why they've made certain choices and not other choices. So that's all useful information. That sort of design doc stuff is useful for any project, and the fact that they often come with crypto projects, I think, is useful. But I haven't done that before, and I haven't really looked closely at the Brave white paper on its own, and I'm not sure what would be useful to say about it in terms of understanding the code base. So I'll keep that as a something I can pull up during the session if necessary. But I'm not sure. I don't think I'm going to go through it, before we look at the code or anything. So I'm on the GitHub repo. I think on Wikipedia. Let's pull up the Brave browser Wikipedia entry. So Wikipedia is telling me that the repository I'm looking at is for Android, Windows, Mac OS, and Linux. So most of the stuff, and then iOS, the iPhone, I guess, and the iPad get their own repository, which I'm not going to look at just because we're going to look at one, and we might as well look at the one that covers most stuff. And this would, a mobile app is typically pretty different from a native app. And this tells me that Brave is written in JavaScript, Swift, and C++. It seems like the Swift will be part of iOS for sure. And the C++ Chromium is written in C++. And then if we go to GitHub tells us that this repo is 100% JavaScript. So I don't know what that means. We'll take a look at it. And okay. So this repository, I'll take a look at the README. This repository holds the build tools needed to build the Brave desktop browser for macOS, Windows, and Linux. In particular, it fetches and syncs code from the projects defined in package.json and source/brave/deps. Okay. And it's going to fetch Chromium. Okay, Brave Core is maybe what I should be looking at. So let's look at Brave Core and let's look at AdBlock Rust. So these are separate repos. but they're, I guess, morally speaking, the same project. They could be in a mono repo, and they kind of are if they're using something like Git modules, but kind of sounds like they're not, and they have their own thing that pulls and stuff. So let's look, I guess, at least quickly at Brave/Brave dash browser, and then we'll move on to Brave-core and AdBlock Rust. And I believe I read somewhere that Brave had another. I think it's maybe in Wikipedia. So let's look at. Okay, so in June 2019, Brave started testing a new ad blocking rule matching algorithm implemented in Rust. Oops, I didn't mean to click on that. I meant to highlight that. So replacing the previous C++ one. The uBlock origin and ghostery algorithms inspired the new logic, which Brave claims to be, on average, 69 times faster than the previous algorithm. So what does that mean? One is they started with some C++ algorithm. They probably cribbed some stuff from uBlock origin and ghostery. Those are mature projects that are specialized in kind of intercepting browser requests and modifying them so they're more consistent with how the user wants to browse the internet. And so it makes sense to crib some logic from them. And an average of 69 times faster than the previous algorithm, that's a huge multiple. So that tells me that maybe the old algorithm was not very fast. And normally when you have something that's slow, what's the way to say this? It's always tempting to do a complete rewrite. And it's kind of a trope that, if you have something in C++ to rewrite it in Rust or to rewrite anything in Rust, you see people kind of like joking about this on the internet, how everything needs to be rewritten in Rust. So it's a little bit unusual to me that we have, not unusual, but it's a little bit interesting to me that we have a formerly slow algorithm and a complete rewrite of the ad blocking stuff, especially since ad blocking is seems to be a big part of the sales pitch for Brave. So I think that's worth looking at just to see what they've done and to see if it's I think in some sense that's going to be the heart maybe of Brave. There's of course all the token stuff, but we'll see if we can find any token code as well. So in source we just have .getKeep, which I'm not sure what it is, and it just has the line getKeep. Okay, maybe it's the opposite of getignore. And then I guess we have scripts, init.js. So this is going to be some JavaScript that I assume is going to do things like pull in the code. Okay, so Brave core. All right. So we're going to call it, we get whatever these are called, these like little tooltips that I guess in GitHub, I don't use many GitHub features. But I guess in GitHub, you can configure your repo, maybe if you pay them more money or something, to have some sort of understanding of the code, or maybe it's some sort of plugin. At any rate, we have like little tooltips that will tell us maybe where things are defined, and we can go to util.js. But it's going to run Git. Presumably this just shells out to Git, and it's going to do things like clone Brave core, which is the repository we have opened here. So that's what this script does. There's not much else, it seems like, in this repo. So potentially this whole thing could be replaced by Git modules. But maybe this predates the widespread use of Git modules in some sense. I don't remember when Brave browser was created. What have I done? Okay. Let's see if we can get a timeline. Initial release 2019. When was Bitcoin? Was that 2018? Oh, 2008. I'm 10 years off. Okay. 2009, I mean. All right. So for some reason, 8 was in my mind. I guess I dropped I guess I was off by one and then off by an additional 10. Okay, so this is the initial release is 10 years after Bitcoin, and then the history starts in, I guess, 2015 with Brendan Eich, who is somehow related to Firefox. Oh, he was at Netscape. Okay. He joined intending to put Scheme in the browser. So Scheme is a Lisp, so that would have been interesting. Maybe that was an alternative to JavaScript. But his superiors insisted that the language's syntax resembled that of Java. Okay. So if this guy had been in a better position to fight whoever his superiors, his Netscape superiors were, then maybe we would have had a Lisp based browser language instead of JavaScript, which would have been cool. That would have made browsers more like Emacs, I guess. Um, so okay, he was the co-founder of the Mozilla project with Jamie Zawinski, and AOL bought Netscape in 1999 and shut down the browser unit. Okay, so and Ike was the CEO of Mozilla. And then at some point he leaves to do Brave. Okay, so that's his like pedigree. That's where this stuff is coming from. So super uh, old school in terms of web browser history, and that I think alone makes Brave really interesting. Um, okay, so we're back at the code. This is the util.js stuff. I guess let's see what they do with Git. What's it called? Run Git or something? Run Git is going to call run, and run is defined up here. And it's going to take the name Git. Presumably that's just the repo. Wait, hang on. Okay, yeah, repo path, Git args, etc. So it's going to call run with the string Git, which is not the full path, but that's enough, I guess, for the shell to figure out where Git is, right? You can just call which or whatever, it'll just search the search path. Okay, but let's look at run. I'm going to guess this just calls the command line. So we're going to log command options, define some stuff based on options, I guess, unpack options. If prog status is not 0, continue on fail. Okay, so I guess, yeah, all right. So prog is going to be spawn sync command args. So spawn sync, whatever spawn sync is, require child processes. I'm going to guess this is a JavaScript thing. Child processes, or maybe it's a node thing. So I guess it's going to synchronously execute a command. It's a command to run. History. I don't care about the history. Okay. Well, it doesn't say what it does, but maybe it will, I mean, not at the top anyway. All right, so synchronous process creation. So it's going to run Git synchronously. Okay, so that's what that repo does, whatever it was called. Brave something or other. Brave-browser. So now let's look at Brave-core. And we've got a lot more stuff. Do we have a README? We've got a documentation wiki. I guess let's pull that up and bookmark it and then close it. All right. So let's just see what sort of stuff is in here. We have V8. So maybe this includes the Chromium source code. We have vector icons, win, build, output, test, renderer, resources. In fact, let's pull up Chromium. Chromium.googlesource.com. Chromium, I guess. There is a better interface to this, right? So let's see if we can find it. Chromium source code. There's a GitHub mirror, I guess. All right, so here's Chromium. let's do Chromium on the right, maybe, and Brave Core on the left. Somehow, I think if I can move this, okay, here we go. All right. So Brave is on the left, Chromium is on the right. I'm just curious if these are the same folders and everything. So we've got Chromium source in the Brave core thing. And we don't have a bunch of other stuff we have here, like dbus and whatnot. Let's look at Chromium source. I'm wondering if this is here. Yeah, okay. So Chromium source seems to be the Chromium source code. So it's just kind of copying and pasting the Chromium source code without some stuff, maybe like without Chromecast or Chrome OS or Code Labs. We do have Chrome on both sides and components. Whoops, components are there. And crypto. All right. And V8. V8 should also be on the right here, I would guess. Maybe not. Maybe V8 is somewhere else. Okay. So that seems to be more or less what's going on. Maybe not exactly what's going on in Chromium source. So let's kind of black box Chromium source for now. Let's look at fuzzers. Maybe extensions. There's a Brave AST patch in Mojo. And I think maybe when we looked at Chromium before, Mojo was some sort of IPC or inter-process communication configuration that was maybe similar in spirit to protobufs, but specialized for inter-process communication rather than communication over a network. Renderer, I guess let's look at script services. Sure. Tools, maybe. UI, V8. So there's also, so in Brave Core, there's Brave-Core/V8. And there's also Brave-Core/ like Chromium source/V8. So whatever this V8 thing is, I expect it to be different from what's directly copied from Chromium. So I guess we'll take a look at that to see if they made any customizations or changes. And then components, common, browser, base, and app all seem useful. I wonder if I clobbered the Rust thing, but let's see. Let's like look in the Rust ad block window before we go too deep into the Chromium core. So Rust also has fuzzing. That's good. It's got JavaScript, I assume is what JS is. Benches is presumably benchmarks. And source and some tests. All right. How would you pronounce that? Maybe Bukala? Says, hey man, recently found your channel and I gotta say, amazing content. Thank you a lot. I really appreciate it. That means a lot. All right. So I'm a little bit okay. I'm a little bit nervous that there's going to be too much here for me to give to get a good sense of going on. So this may be a long video, but at the risk of using up time to look at core, I want to at least get a sense of what's in this ad block Rust thing, so that I'll have maybe more of an internal sense of like how quickly to go through core or whatnot. So we've got fuzz targets, and these are written in Rust. And I'm not sure. Okay, ad block list, libfuzzer, sys. I'm going to guess libfuzzer, sys is a general Rust thing. Oops. Yeah, okay. So they're using some sort of Rust tool, and this is maybe mostly like configuration to tell it how to fuzz specific things. So like, for example, from URLs, I guess, they're going to fuzz somehow and check that, you can't inject nasty things or break their system. We have example.js. So we were in the adblock Rust JS directory. And we have index.js, example.js, and some cargo stuff. And then lib.rs. We got engine options. This is the definition. Okay. Filter set, finalize, create filter set. Okay. All right. Filter set into content blocking. Okay. So I guess filter is like an ad block filter, similar to what you might see with uBlock Origin. Benches is, I guess, benchmarking. They're going to benchmark the. Let's just verify it's benchmarking before I before I go too far down that route. Let's see. Bench simple regexes. Bench joined. How will I tell if it's a group.bench function? Group.bench function. What are we importing? Nothing, I guess, super interesting. Criterion? Maybe criterion is a statistics-driven micro-benchmarking library. Okay, yeah, so these are benchmarks. And without going too deep into the benchmarks, what are they benchmarking? Regexes. Yeah, you want, if you're going to run an ad blocker, then you want great regex performance because you're basically running, presumably, a regex on like every kind of request, everything you get back from a request. Bench matching, some sort of matching logic. Cosmetic matching, who knows? Redirect performance, I guess this is for redirecting. And then some rules and URLs. All right. That seems like stuff that's good to benchmark. And then here's the source for AdBlock Rust. And it's not a ton of stuff. We have a URL parser, which I think I can mostly ignore. Although maybe it would be interesting to learn why they have their own parser rather than using something off the shelf. Maybe sometimes that means that the existing parsers weren't working for them, or maybe there wasn't a great Rust parser at the time they started. I don't know. Or it might just mean that for whatever reason, this ad block stuff needs a URL parser that has features or performance that isn't in other such that the gains of maintaining their own version outweigh the costs, I guess. But we also have filters, resources, and data format. All of this stuff, we can kind of guess what it's going to do. You're going to give it some sort of filter, and it's going to peek at requests and see whether a filter matches. And if a filter matches, it's going to somehow patch like the JavaScript or the HTML so that whatever a filter is going to be essentially regex and some kind of action or something. And so we're going to match the regex, and then we're going to apply the action, which is presumably kind of like patching something. So I'm guessing that's what's going on. Filters might be especially interesting because the way that you design your filters is going to have, I imagine, a huge impact on performance. So that's what's in AdBlock Rust. I'll leave this open in this window, and then now I'm going to return back to Brave Core, and then I guess we'll do AdBlock Rust kind of at the end. So that's what I'm thinking now. Okay, so let's see. So in Brave Core fuzzers, and we're going to fuzz AdBlock, Brave News, Brave Wallet, Speed Reader, and we've got this build file. I don't know what GN is, but it's some sort of build file, I assume. This looks like code. We're going to import and asserts. Released under the Mozilla public license. Okay, that's kind of interesting. I don't know. Looks a little bit like Bazel, but it's got curly braces. I'm not sure if this is something they made up or if this is. I guess let's look up the GNI file extension. GN language and operation. All right, maybe this is from Chromium. Yeah, okay. It's extremely simple. Hmm. Wonder what the GN stands for. The GNA file is Visidac. Okay, I think that's a different. Uh, yeah, this seems to be what this looks like to me is whenever Chromium open sourced, maybe they like wrote a new version of like Bazel build files before Bazel got open source, while it was still only used internally, maybe, and that's why it looks like Bazel. But maybe they did it with like JavaScript or something, or based on JavaScript, and that's why we have things like curly braces. I'm not sure. There might be some interesting docs on this, but this is some sort of build file. It's used for building. I'm not going to go too much deeper into it. Here in this extensions library, extensions directory, we just have the build file. We'll do things like check if it's Android, in which case we have a bunch of extensions like extensions /common, etc. But I don't see these in the code, so I'm not sure where they come from. All right. So what are the extensions? Error utils, URI patterns. Okay. All right. So here we are in Mojo /Brave AST patcher. We've got a build file, which we'll ignore, and a test module. Let's look at what they're doing with Mojo. This file contains patched MojoM usage, or Mojam usage, to ensure that all new definitions, values, and members are properly added using the patching mechanism. Okay. We've got global interface impl, and it says create interface implementations to ensure new methods exist and are overridable. And new global interface impl. And the global interface thing has things like test nested enum, test nested enum. So these are like test functions. And where are we? We're in C, right? We're in C++. So this is not a Mojo file. This is a C++ file for maybe managing Mojo stuff. We include the Mojam header in gtest. And this is a test. Okay. And we're going to call things like expect equality between global enum value and 0. And some constants. So, okay. So this is pretty straightforward in terms of like what it's up to. In terms of like why it's up to this, I don't have as much of a sense of that. Here's a Mojam, and we don't get syntax highlighting, which is not surprising because I think Mojam is only existent in the Chromium code base essentially. And I see. So we've got global struct, nested enum, global enum. So I guess what they're doing is maybe this is a way for their code base or CI or whatever to fail if upstream Chromium introduces some sort of incompatible change to Mojam. That's just a guess. I think it's that sort of thing based on the comments and based on what's in the code. Okay, so here's the renderer, and we get Brave Wallet. Why is Brave Wallet in the renderer? I don't know, but we also have SKUs, which are I have no idea what SKU stands for now that I think about it, but those are the like barcode. They're like a unique identifier that you identify with some sort of product offering, right? So we'll take a look at what's up with that. What could it be? Yeah, I'll look up SKU. Stock keeping unit. Okay, so stock keeping unit. It's the unit, I guess, at which you keep stock. Or to put it another way, it's a distinct type of item for sale. Yeah, purchased or tracked in inventory. Okay, sure, that makes sense. All right, so we've got tests for the renderer, and then we've got Brave Content Renderer Client Brave Content Renderer Client H. So let's look at the header files for Thread Observer and Renderer Client. And I guess let's make sure we're closing as we go. And I'll ignore, I'll ignore test for now. All right, so Brave Wallet Renderer frame observer.cc. Yeah. Look at depths. What is the wallet going to depend on? So this might just be the UI code for rendering the wallet rather than the wallet itself. So there might be another place for the wallet. In fact, I'm gonna come back to renderer. I'd like to look at something more core. So we have services, tools, UI, V8, components, common, and browser, and base. Base doesn't look very populated. And app. Let's look at browser. Let's look at this. So I think one of the original questions that was asked in the comment that spawned this fan request Friday was like, why are some browsers faster than other browsers? And I suspect, well, first of all, I don't think we're not gonna be able to really answer that question. The real answer is that often it's like death by a thousand cuts. What makes something fast is there's a lot of attention paid to bottlenecks and improving them. So sometimes something will be slow because the algorithm is slow. Like you're doing linear search when you could be doing log linear search, or you have like quadratic search. And sometimes that's easy to find in a code base. And sometimes it's not easy to find because essentially the behavior that causes something like a quadratic search is spread out over many files. And so really, if you want something fast, you have to not just, having benchmarks like they have is good, but you have to run it under like a profiler and see what's taking up time and kind of like focus your attention on those things. I guess I won't say anything more than that, but you can get fancy with that sort of stuff. And when you have something like Chrome, if you're the Google Corporation and you have something like Chromium, then you can pay lots of people are running Chromium. And you can pay lots of engineers to iron out bottlenecks. So that's how something gets like really snappy and fast. Assuming already that you're like, what's it called? Asymptotic runtime is where it should be. And then there's stuff like, implementing something in an interpreted language might be a little bit slower, depending really on like, whether your thing is network bound or whatever. But comparing two browsers, a lot of times the performance differences will be not very noticeable if you're just looking at the code. That would be more like figuring out that would typically maybe be more like a research project that would involve a team, and coming up with a plan and running it under different conditions and keeping profiles and stuff. But that aside, there are other things that can make something slow, and that would basically be additional features. Like if you want to support an additional feature where, just to pick an arbitrary example, like if you have a blog and you want to add like a social media button. I don't know what social media buttons people have now, but for a while they were like Facebook buttons or Twitter or Instagram buttons. Like if you add new code to your thing that calls now out to a Facebook API, then those new API calls to external machines take additional time. So as you add new features, if those features are using stuff from the internet, that can take time. Or if you add new features and those features need to compute stuff, that can also take time. So since I see a bunch of branded stuff here, I think that's one place to look at to see if part of what's going on is like they've added features. and those features are doing work. And if the user is having to wait for that work, then that might be slow than not having the same features. We have browsing data. I don't know what that is. Component updater sounds interesting, potentially. Content settings debounce gets its own folder. All right, look at debounce. Decentralized DNS has only a test directory. And we have ephemeral storage, Ethereum remote client, farbling. I have no idea what farbling is. GCM. I'll look at GCM driver, geolocation. IPFS. Info bars has its own directory. Metrics metrics might take time or resources. New tab. I'll look at new tab just because sometimes new tab implementations can be have a lot of features. Notifications. NTP background. What is NTP? The time protocol, maybe. Whatever P3A is. Partner customizations, perf. Permissions. Yeah, I'll look at all this stuff. Playlist, policy, preferences. Profile resetter, I'll ignore profiles. Renderer, context menu. I'll skip it, I guess. I've got to skip something. Safe browsing. I'm wondering how much of this is also pulled from Chromium. Search engines, sessions. Yeah, look at sessions. Sharing hub, SKUs, more SKUs. Speed reader, sync, Tor, translate, UI, URL sanitizer, web discovery, package. And then I think Widevine is like a DRM playback thingy, similar in spirit to Flash. I think back in the day, I think it might be a Microsoft DRM being digital rights management. It's a way to like do things like play multimedia over the internet and disallow people who don't have your permission from watching whatever you're serving, right? So, okay. And then we have a bunch of files on their own, like about flags, Brave browser features, Chrome, all right. Profile preferences, tab helpers, update sources.gni, I guess, is the same thing as the build language. All right, so let's try this, and then I'm going to look up the Chromium source code again, just so I'm not spending too much time on Brave stuff that is really Chromium stuff. Here's Chromium. We've got Chrome and Chromecast. Let's see, do we have browser? Not as a directory. But let's look in Chrome. And we do have browser here. And we have maybe some of the same stuff. Battery, bookmarks, breadcrumbs. See if we have this stuff in Brave. No, not really. Okay. Captive portal. Okay, so this Brave stuff seems to be different than what's in the Chromium codebase. So, okay, Brave adaptive captcha, and we just have some sort of service factory. See what it does. All right, we're going to include base memory singleton. So this is, I guess, some sort of singleton pattern where. Actually, no, we have to look at this. Base memory singleton. So I'm guessing that what's going on here is it's like a singleton in the sense that there's only one of these ever created, and it's going to service calls from other directories. And it's a service factory. So what I suspect will happen is, I don't know what the pattern is called, but we essentially lazily initialize a singleton, a global variable, essentially, that will provide the adaptive CAPTCHA service. And the first time it's requested, it'll be initialized. And then every additional time it's requested, you'll get a pointer or a reference to the thing that was already created. So I'm going to guess that that's what we're doing. And presumably, since they have this thing that's called base memory singleton, presumably they do that all over the code base for their code. So if there's some way in which this happens to be slow, that might be a source of slowness for all services. I don't suspect that that's the case because I don't really know how you would get that wrong, but I also don't know too much about. I mean, that's really a question about making sure you understand how source code is compiled into machine code, and also like what kind of optimizations the typical processors do. Those sorts of questions enter into something like how fast can you possibly make like a singleton service or something. I think if you're at the tail, once you've got your other ducks in a row, and if you want to squeeze out additional performance, I think those are the sorts of things you have to think about. Okay, so we're in this captive namespace. We have this public factory. We have get for profile. So you're going to pass in a profile, and you're going to get a pointer to the adaptive CAPTCHA service, which is consistent with what I was thinking. And we've got get instance, which is a common way to get the singleton that you've created for whatever. So I don't know, but maybe get for profile implies that there's more than one of these singletons. Maybe there's like a singleton per profile. And I'm not really sure what profiles do, but you could have you have different configurations, I guess, of your browser, and I think that's what profiles are. I don't know if you can. I guess you probably can run multiple browsers under different profiles, in which case you presumably would want the services not to all be shared between profiles because you'd want some sort of isolation. Okay, so this is the header, but we'll look at the CC file to see what get instance actually does. Because I'm going to bet that it does the singleton thing. All right, so we've got a static function, get instance, that's going to return base singleton. Yeah, okay. Brave adaptive CAPTCHA service factory.get. And that's just wrapping this factory thing inside of this base singleton and calling get on it. So base singleton is somehow a pointer, maybe a reference counted pointer, or a unique pointer or something. And get is going to get the underlying non-smart pointer. So presumably some sort of smart, I think they're called smart pointers maybe in C++. A pointer that is less dangerous than a raw pointer, but you can get the raw pointer out of it by calling get. So let's see if we can find, what was it, base memory. Oh, look, here's base memory, raw pointer. All right, that's more evidence for my conjecture. And where is that used? Do we use anything called raw pointer? Okay, so context returns a raw pointer to a browser context. Okay, I'm not sure what that is so much about, but all right, let's see. Back in the header file, we have base/memory/singleton. And I'm going to guess, all right, so base. No? Maybe it's relative to browser. All right, base process. I guess I could look in the build file. Is there an include directory? Or what's the other thing people call it? I don't, maybe contrib. All right, let's try looking at we have a build file. Let's try looking at the build file to see what the dependencies are. All right, where were we? I'm not sure I'm going to get there by clicking back repeatedly. Yeah, I will. Okay, so let's find the build file. The Brave browser, blah, blah, blah. Memory. Hmm. Hmm, hmm, hmm. I guess I'll just look for singleton.h. I don't think GitHub will let me search. We'll see. Yeah, of course not. But let's see, do I have Emacs or something? Okay, let's see. I think I have Brave. Oh, but I don't have okay. I don't need this Brave browser repo. I'm gonna go ahead and clone Brave core. And then I'll look for singleton.h. All right, while that's working, I'm in Brave ads, which is different from the Rust-based ad block stuff. Okay, we've got an ad service factory. That's I'm now willing to bet $1 that this is going to do exactly the same singleton things. All right, so we've got the memory singleton. I'm going to guess we have a get instance. Okay, so this is a pattern I'm going to guess we have all over the code base. So Brave stats helper, ads tab helper, an ads tab. What is an ads tab? An ads service. Maybe there's a tab full of just ads. And while this is going on in Emacs, I guess I should check if I can run if I can install Brave here. See if Geeks has Brave. I'd be kind of surprised if they did. All right, yeah, they don't. I'm sure there's some easy way to install it, but I guess I'm not going to do that right now. But maybe we can look at a screenshot. Ads tab is really what I'm curious about. These are all nice screenshots and whatnot, but I don't see anything that looks much like an ads tab. Maybe this is it. Okay, so it's going to tell us the number of ads blocked. 33,000. So I don't think this, yeah, okay. So this must be for an individual instance. This is not like Brave bragging about blocking like 6 billion ads or whatever across all users. So somehow 33,000 trackers and ads have been blocked in this screenshot. You've saved 34.5 megabytes or megabits. I think megabytes is capital B of bandwidth and saved 27 minutes. Okay. Maybe that's the ads tab. I don't know. But let's take a look at some of the stuff. It's got a session ID, a tab ID. It's got a weak pointer factory. Somehow a weak factory. Media started playing. Media stopped playing. Did finish navigation. Document onload completed in primary mainframe. On JavaScript HTML result, tab updated in run isolated JavaScript. So presumably some of these are from whatever it's inheriting from. So adds tab helper inherits from web content observer. So it implements some content observer interface. All right. And if we're on Android, then we have things like on browser set last active. Okay. Well, I don't know what an ads tab really is doing, but this is some sort of tab thing that can you can check whether it can run isolated JavaScript. You can have some updates if media starts or stopped or if visibility changed, kind of UI stuff. I'm not really sure what that's about. So ads service factory. Let's look at the ad service factory implementation. We have a search result ad. And And I will look at the header and implementation there. And we have a background helper for Android and for Mac and for Windows. We'll look at the headers for add background helper. So here's the ads factory implementation, the CC file. Did I also open the Okay. So let's see. We've got some static get. We've got a static get instance that's going to return the singleton as before. Here's the add service factory, I guess, constructor. I guess it takes some sort of key, maybe a human readable key that says it's the add service, and a pointer to the browser context dependency manager. And we're gonna tell it it's gonna depend on stuff, including notification display service, Brave rewards service factory, history service factory, Brave federated. Okay. Brave federated service factory. Okay. So maybe one, honestly, I'm just shooting from the hip here. I don't, if I say something about optimization, take it with a grain of salt. I'm trying to provide my thought process, which may not be a refined thought process. So if it's my job to do something with code, then I would go through the code and brainstorm and write stuff down. And then there would be a process by which you refine the brainstorm results and throw away the ones that are not good after thinking about them for a bit. But one thing that I guess immediately comes to mind as a brainstorm thing is that there may not be a clear separation between which of these dependencies are critical dependencies and which are non-critical or optional dependencies. So, like for example, the federated service factory seems like it might not be critical for the ad service. It might be, I don't know. But if it's not critical and you don't have that kind of clear separation, then sometimes you can have situations where something is waiting on something else and that the thing you're waiting on is not critical. So there might be some optimizations where you can essentially say that, if this thing is slow, then you have to wait. But if this other thing is slow, then you don't have to wait. You can just proceed and we'll not populate that window or whatever. Okay, so we've got this thing to create tooltips, and it's going to, I guess, delegate. Or it's going to return some sort of delegate object. A keyed service. All right, so build service instance 4. This is something to build the service. And we're going to get the history service. We're going to call get for profile and all of this stuff. And we're going to call it one at a time. I don't know how often do we add service, build service instance 4, the browser context. Okay. So do we save this thing? Add service release. Anyway, we're going to configure all this stuff. And then release, I guess, the pointer. It's going to give us a keyed service pointer. And then we have this thing that just tells us whether it's null while testing. Okay. I don't know how often this function is called. If it's called a lot, it may make sense to kind of, instead of calling get for profile on a bunch of different stuff, maybe have a single place where all of this stuff can be gotten or cache it, those sorts of things. My guess is that since we're dealing with singleton stuff, my guess is that this is not called often, maybe once per session or so. All right. I was waiting for something, right? I was waiting for, I think, git clone. Did I shut my Emacs? All right. And I think I want to, I think I just want to find, and what was it, singleton.h? I think I need to pass in a, like that. just for completeness. No. I forgot to tell it that's the name. Okay. Maybe I'll try grep. Did I spell that right? Oops. All right. Where now? Where was that? Grep. Okay. So we do have a lot of imports of the singleton.h stuff, wherever base memory is. But we don't seem to I don't think this is doing anything useful if I do this, but just out of curiosity. Yeah, okay. So I don't see this file. Maybe it's maybe it's more general than Brave. It's a Chromium thing, I guess. Please read, do you really need a singleton? If possible, use a function local static of type base no destructor T instead. Factory and factory get instance static base no destructor factory instance return star instance. Singletons make it hard to determine the lifetime of an object, which can lead to buggy code and spurious crashes. Instead of adding another singleton into the mix, try to identify either A, an existing singleton that can manage your object's lifetime, or B, locations where you can deterministically create the object and pass into other objects. If you absolutely need a singleton, please keep them as trivial as possible and ideally a leaf dependency. Singletons get problematic when they attempt to do too much in their destructor or have circular dependencies. Yeah, okay. That was a much sterner warning than I was expecting. I thought maybe singletons might be bad sometimes, but this warning is, is basically saying, um, try not to do this. So could that be one issue with Brave? I don't know. Are they using? Is the pattern that Brave has similar to what's going on in Chromium? And they're just like adding new versions of kind of the same sort of stuff. That's possible. It's also possible that that Brave is overusing it in a way that like the Chromium team would prefer not to happen. I swear there's some sort of Chromium code search because I was at it before. Codesearch.chromium.org. That looks about as promising as you can. Could not load project. Yes, you can. I believe in you. Huh. That's too bad. Is it a geeks issue? Let me try off screen here. Hmm. Seems to be a geeks issue. So let me load in this other tab here. All right. So here's Chromium, and I'm just going to search for singleton.h. Okay, so we've got, this is the singleton.h file. We've got process. Okay, so here's singleton hwnd. Let's try looking for import. Let's see, how do they write it here? Base memory singleton.h. I don't know if I can do this, but I'll try two types of quotes. That didn't work. Okay. So we have logging, services, URLs, settings. Mobile activator, global descriptors, arc memory, bridge, in-memory URL, sign-in error, history service factory. Okay. Safe browsing metrics, cookie settings factory. Yeah, so it seems like this factory thing is also in the Chromium code base. Let's see. Yeah, okay, so we have this get instance thing. And can I go to related files? Hey, look at that. All right. Yeah, so maybe get. Yeah, okay, so get is going to return a base singleton. Okay, so this pattern is in Chromium, which is good to see. But Chromium still has the warning, try not to overuse singletons. Okay, so where we were in Brave add search result. If search result add tab helper, maybe create for web contents. Don't know what that means. Maybe retrieve search result add. And it's going to take a render frame host star, and it should trigger viewed event. Where are they getting these ads? Set ad service for testing, get ad service, did finish navigation. So search result add. You would think that uh, like Google and Bing and whatever other search engines there are, Yahoo, Yandex, you would think that they're going to return their service, their search result ads to you directly as part of the search interface. So if Brave is is implementing their own search result ad stuff, I guess my initial question is, are they pulling additional search ads from some service either that they run or some third-party service? So that's kind of my question now. And wow, GitHub is being super slow. I have no idea why it's doing that. I guess I'll move on and come back to that. Search result add tab helper.cc. Oh, this is the implementation, I guess. All right, Brave ads. Yeah, this is what I wanted to look at anyway. Okay. So we've got an ad service, which we're going to set the null pointer. Check for ad with data placement ID visible. And this is I forget what you call this, but basically a string, like a verbatim string. And this appears to be JavaScript. It's a function that's going to call document query selector on for this div, I guess, that has identifier placement add ID to $1, which is maybe somehow passed into this function imperceptibly. The ID is visible. Maybe it's a global variable. If no element, we return false. Otherwise, we're going to get computed style of the element and set that the style and return style display is not equal to none and style visibility is not hidden. So I guess we're going to check whether we should display an ad in some window. And we've got the search result add tab helper. All right. Maybe create for web contents. We're going to decheck. This is some sort of decheck I remember from Google. This is probably part of the Chromium code base. It's basically like kind of like an assert, I guess. I don't know if it fails or whatever, if web contents is false, but it does something to let you know that something bad happened. If this is like wrong or I guess null. And we're going to check whether it's enabled. Brave search result add confirmation events, or whether there are no web contents, or whether browser context is off the record, in which case we return. I guess we bail out. So these two make sense. You're off the record, or there's no browser context, I guess. But what is this one saying? So we have not enabled add confirmation events. So I don't know what that feature is, but I find this a little bit confusing, but maybe if I thought about it for a second, it would be less confusing. Okay, so create for, and then we're going to call create for web contents on web contents if we haven't bailed out. Search result, add tab helper. We have a girl, which I think is a Google URL. And it's a navigation. We're going to take a navigation URL. And if search result add handler, which seems to be a like either a class variable or a static variable, then we're going to maybe trigger search result add clicked event. So maybe it's not pulling in new search result ads. Maybe it's tracking whether you've clicked search result ads. Set ad service for testing. That's some testing function. Get ad service. We profile stuff, whether we finish navigation, whether we should get restore type, document on load completed in primary mainframe. This is kind of like listener events for web browsery stuff. Maybe process search result add. Yeah, okay, let's look at maybe process search result add clicked event, which will take a navigation handle, which I'm not sure what it is. We'll decheck it. Okay, get initiator origin on the navigation handle. If it's in primary mainframe, sorry, if it's not in primary mainframe, I don't know what a mainframe is. I guess maybe these are like iframes, like frames of the internet page, the web page. So if it's not in the mainframe, maybe that means it's like on the side. Is Brave maybe serving ads in an iframe? I don't know. Let's find out. So if it's not in the mainframe and the page transition core type is not page transition link, and the initiator origin is false, whatever that means, and the allowed host is not the initiator origin get URL, then we'll return. Oh, this is bailing out. I thought this was the end of the function, but okay. So this is just some checking. All right. We've got original web contents. If the original web contents, okay, we've got search result add web contents. We're going to get the first web contents in live original opener chain. Live original opener chain. I guess the unmodified or like unmolested web contents are the original web contents. And we're going to set that to the search result add web contents. Okay. Get some decheck on the redirection chain. We're going to get the redirect chain, maybe trigger search result add clicked event. I think that's the end. Huh. I don't have a sense of what they're doing. This would probably be answered by kind of looking up whether, I think Brave serves you ads, right? Does Brave? Its own ads, maybe, is the question. An introduction to Brave's in-browser ads. All right. Why do things this way? Blah, blah, blah. Okay. Yeah. All right. This is what I'm looking for. So advertisers, I guess, have some sort of contract with Brave Ads Server, which has all of the ads in a database. And from their ads server, they're going to do something, maybe call the Brave Ads ML pipeline, like machine learning, I guess. And right, and the publisher, creator, and other sites. I guess the Brave browser is going to request the content from the publisher, and whatever this 5 thing is, we've got databases. I guess these are like the local databases. All ads for the region and local user model are going to be inputs into notification, maybe. I'm not sure how to read this chart, but and then we're going to pull ads. Okay, so wait, let's go to 5. What is 5 doing? Ad notifications are reported via a privacy reporting protocol. Okay, when matching ads based on browsing behavior on sites of publishers and content creators, 4 and 5. Okay. All right. So what's going on? Well, you're going to browse the web with Brave and you're going to download stuff. And Brave is going to inject ads that are given from advertisers and I guess unrelated to the publishers, creators, and other sites. Brave is like acting as a third party. And I guess the assumption is that you like Brave's ads or you haven't disabled them, or I don't know if they're undisableable. Who knows? But they're going to like inject ads into your experience and maybe you get some tokens for viewing ads. Who knows? And by who knows, I mean probably everybody who uses Brave knows. Um, and they've got some sort of machine learning pipeline that's going to try to show you ads that it thinks you will interact with or click on or whatever. And it's going to report back statistics using what it calls a privacy preserving protocol. Who knows what that privacy preserving protocol is or whether it's actually privacy preserving? That's in general a really hard problem. I think probably a research problem. So presumably some information is leaked, and we'll guess that Brave doesn't actually look at it because we'll assume that they're operating in good faith. And okay, so it looks like they do serve you ads. I'm not sure if there's any like thing to look at in terms of what they look like in the UI. So here's local machine learning. So what are we going to do? Blah, blah, blah. It's offline in the sense that it doesn't involve the browser. The models are trained on publicly available data sources like Common Crawl, where one of the key challenges is generating accurate labels at scale. After QA, models are periodically published and downloaded by the browser. The browser then uses these general purpose models to make predictions on ad relevance for a given user's browsing history. It is worth mentioning that we never try to infer interest on login-based websites like your email or social media. Okay, so what is it saying? It's saying we're going to train machine learning models, not on your data, but on some publicly available data. And then we're going to push a machine learning model, which is essentially some code or like weights for a neural network or for a statistical thingamajiggy. And the code to determine which ads to show you runs locally. That I think is what it's saying. And then this thing seems to imply that you have all ads for your region as a local database. Or at any rate, I guess the idea is that like maybe they periodically push you all ads or you pool all ads. But I think the idea is that like by having essentially a cache maybe of the possible ads, they can't infer anything about your browsing behavior based on the fact that like which ads you look at is now a local. That information is now only locally contained. It's not broadcast over the internet. Let's see if we can find out more about all ads for region. Non-campaign specific ML models are trained. We saw that one. Okay. Advertisers create and run campaigns that are disseminated through the Brave ad server to all browsers in a given country. Okay. So I'm going to interpret this to mean that you do download basically all the ads. Like if you have Brave browser, there's probably some file, like maybe a SQLite file that you can open up that will have all of the ad data. Maybe it's encrypted. Who knows? But that'll be at least my mental model. Okay. So this does seem to decide whether to serve you search ads, I guess, based on the local, what's locally on your disk. Background helper.h is pretty like basic. Here we are, Brave Federated Service Factory. So this, I guess, is going to look like one of these singleton services. And I want to know more about what are the federated services. Service created with browser context. Okay, so I guess we don't get that here. Maybe in the imports. We have Brave/components/Brave federated. Let's see if we can find components/federated. Brave ad block UI. Body sniffer. Let's look at body sniffer and Brave ads, I guess. Brave DRM and Brave Federated. We have a private CDN, a perf predictor. Yeah, we're going to be here forever, I think. Okay. Brave Sync, Brave VPN, Brave Wallet. All right. And maybe browser UI. Challenge bypass. Filecoin. And more IPFSs. Okay. So I'm going to try to look at this stuff really quickly. All right. Body sniffer. I'm just, with a name like body sniffer, I think I have to know what's up. All right. We've got weak pointers. A base throttle used for implementing sniffing functionality. It's a throttle. So it's going to take a URL loader throttle and a weak pointer to a body sniffer throttle. And intercept and start loader. And it's got some Mojo stuff. So I guess we're doing IPC. We'll process response. It's going to, I guess, give you a yes or no decision on whether to process. What does a throttle look like? I like that emoji. All right, Brave Sniffer throttle. I don't think that's what I was looking at. Maybe it was. Yeah. So the class Brave Sniffer throttle is going to, I don't know what this means. That is like essentially recursive. Sorry, body sniffer throttle. Maybe this means that it has a public base supports, or maybe just is saying that it supports a weak pointer, I guess, of this type. All right, and then what is the throttle actually doing? Nothing. Not really. It's going to do some Mojam stuff. Intercept and start loader. Intercept response. All right. I don't know why it's called a throttle. A throttle, I feel like, should be about speeding up and slowing things down, maybe? Is that what a throttle is for? And loader. Okay. I'm not sure, but I said I wasn't going to look too long at this. Okay, so here's Brave ads. We've got core resources, content browser, common. Who knows? Search result ad. Ads converting, ads util. Add constants. Add event history, add info, ads.h, ads callback, export database.h. Let's look at database and ads.h. So we've got the GURL class, which I'm going to guess is from Chromium and is a Google URL. We've got time and time delta, and then in the namespace Brave ads, we've got an ads client is supported locale and class ads export. Get diagnostics, shut down, initialize. Called to initialize ads. The callback takes one argument. Called to shut down ads. Called to get diagnostics. User changes. On tab, HTML content did change. User gesture events on tab did change. Yeah, there's a lot of stuff here. History item list. Get history. Called to get history filtered by filter type and sorted by sort type. All right, toggle add thumb up. So I guess you can thumb up. Called to like an advertiser. This is a toggle. So calling it again returns the setting to the neutral state. And here we have called to no longer receive ads for the specified category. So I guess you can like favorite or like ads, and it's a little bit, that gives a little bit of a feeling of that the ad service is perhaps a little bit like the Facebook timeline or the Twitter timeline, where you're going to like things, and those likes are interpreted as kind of like opt-ins to a mailing list of stuff from the same genre. So if you like advertisements about like rainbow unicorns, then you'll get more rainbow unicorn advertisements. That sort of thing is what the ad service seems to be up to. Presumably, a lot of this is laid out in the Brave documentation. their website, the basic attention token white paper. I'm guessing this is all pretty well documented. Okay, so here we are in more Brave ad stuff. What is this file? Database.h. So I'm guessing this is going to be the ads database. We could run transaction, and we're using Mojam, DB transaction info pointer. I would bet it's SQLite. We'll see what's going on. Do they import anything from SQLite? We've got memory pressure listener, sequence checker, adds Mojam, SQL/database, and SQL/metatable. Okay. On memory pressure, we're going to, I guess, maybe emit something. And we have a DB path, a database DB, and whether it's initialized. All right. Can I go to file? What does this do actually? I don't think I can go to the related file, can I? No. See if I can just go to the CC. Nope. Is it just .c? No, there is no C. There's only database. I'm just curious whether it's SQLite. I don't know what else it could be. Maybe find grep SQLite. Oh, that didn't do what I wanted to do. I think I have to put my I thing here before the E. Yes, kill it. All right, here we go. Yep. All right, lots of SQLite files and mostly in test at the beginning. And then what else do we have? Some SQLite stuff appearing here and there. Memoir. Database helper. Java. And Android. So in Android, they use SQLite. I don't know what else they could use. Maybe they're using SQL on it. I don't know if like something like LevelDB supports SQL. But I guess I'll assume they're using something like SQLite. All right, so here's Brave DRM, and this is just a Mojam file. Interface Brave DRM is on wide key system access request. Okay, so this is DRM, digital rights management for Widevine, which I claimed I think was a Microsoft thing, but let's take a look. A proprietary digital rights management DRM system developed by Google. Oh, Google. I was wrong. Widevine is divided into 3 security levels with differing levels of protection depending on hardware present on the device. What's the Microsoft one? Is that like Silverlight or something? DRM streaming, maybe? I don't know. Silverlight? Okay, Silverlight is a discontinued application framework for rich applications. Okay. So it had digital rights management integration. All right, so Widevine is a Google DRM framework, I guess, for streaming stuff. All right. So here we are in Brave-core components / Brave federated. And mainly I want to know what is being federated. We got data store. I guess let's look at what's up with data store and async data store. And eligibility service, features unit test, operational patterns, interfaces, data stores. Let's look at the build file. Federated service.cc, eligibility, blah, 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 all that stuff. Brave stats, browser, P3A, feed service metrics, prefs, data store stuff. Maybe this is for stuff like IPFS support. We saw some IPFS directories. All right, base files, got SQL/database.h. Some training. Oh, maybe this is federated learning, federated machine learning, because we've got training data, which is going to be a flat map with covariate info pointer. Yeah, this looks like statistics. Hey, I will make a video about pandas, but it won't be next Friday. I have my schedule for next week is up, and I have a tentative schedule for the next few weeks. What I'm thinking with respect to pandas is doing a bunch of basically doing themes, maybe like a theme week on machine learning stuff, and I guess as part of that, including things like pandas or NumPy or Jupyter, stuff that people use for machine learning, as well as looking at things like Torch and TensorFlow that are and like maybe like GenSim that actually contain the code to like train models. So I think that's how I'm thinking about doing it. But definitely, I will cover pandas, probably sooner rather than later. I'll also make sure that I'm writing it down actually. Okay, cool. All right. So we're in federated. This seems to be federated learning because we've got this covariate info pointer thing, which with this Mojam like IPC stuff. Let me double check that Mojam is IPC because I've said it like a billion times. Intro to Mojo and services. Yeah. Okay. A message pipe. Yeah, this looks like IPC. Yep. All right. Mojo IPC is used in Chromium. Okay. So when I saw it before, Mojo, you basically think of as protocol buffers or like gRPC, but instead of less heavyweight, more for processes on the same device. And we've got a data store, so we're going to store stuff in the database. It will initialize it, get next training instance ID, save covariate, add training instance, delete training data, purge training data after expiration date. So I guess that will walk some database and if something is expired, delete stuff. And it's going to take a SQL database, not take, but it'll have like a reference to a SQL database in a file path, which is where the DB is located, and a data store task. Okay. Cool. Now I kind of want to look at the implementation. I don't know how it's going to take these covariates and do something interesting with them. Bind covariate to statement. So it takes a reference to a covariate as a Mojam thing, a training instance ID, the timestamp, and a SQL statement. And the statement is going to bind int. So I guess the statement is essentially a template, and bind is going to like fill in at the first integer thing. We're going to fill in the training instance ID. This is basically like I'm guessing like a kind of clunky way to do template interpolation in C++. All right, and then we've got some data store stuff, initialize database, save covariate item. Yeah. Cool. And load training data. For a second, I thought that was loud training data. Delete. Okay. So whatever it's doing, it's storing covariate stuff into a SQL database. And somehow, I guess it's going to use that to do add matching. Here's async data store. Basically the same stuff, except I guess async. Eligibility service. Certain classes of federated tasks might be computationally and bandwidth expensive to run on the client. For these classes, we require the client's device to be attached to power and on a Wi-Fi connection. Eligibility service monitors the device battery and power state to determine if the device is eligible to run federated tasks. Cool. Now, I don't know if you run run federated tasks. I'm not sure if you're training the. I think with federated machine learning, typically you would, I guess, train on your local data and then like upload the trained response. So essentially, you're training for everyone. Based on the documentation I looked at, I thought they were saying that they weren't going to train on your data at all. So I don't know what that's doing, but they kind of make it sound like they're going to, check whether you're plugged in and on a Wi-Fi connection, so that to see if if it's reasonable to use your excess power and internet to do federated training. And that makes me think that maybe you are training for everyone. That they're basically sending you, that it's a little bit like SETI at home or whatever. They're going to send you some computation for your computer to do or for your mobile device to do, and you're essentially renting out your machine to the brave people for training. So let's look up what they're actually doing. Using federated learning to improve Brave's on device. Yeah, okay. All right. So user one, I'm going to just look at, I'll read this. This work on private federated recommendation is only one example of how we intend to leverage federated learning with privacy. This new paradigm will enable us to offer new services, such as local news recommendations. Okay. Federated learning of cohorts. Okay, so sounds like basically they were trying to do federated learning stuff, and Google came out with their own federated learning stuff, and they're a direct competitor to Google because their value proposition, among other things, is that they're going to protect your privacy. The implication is, of course, that Google's ad-driven stuff and their browser is less privacy respecting, which I think is true. But it sounds like Google came out with federated machine learning in a privacy preserving way, or they attempted, and they're criticizing Google's proposal, I guess, post third-party cookies, and for promoting a false notion of what privacy is. So this kind of it's like some catty clawing at Google as a competitor. So here, blah, blah, blah. They have a lot of fluff. I'd like to get to like what is actually going on. They instead rely on handcrafted heuristics. Okay. They build profiles of a user's interest. So it's talking about Google. We don't believe in profiling users. Okay. Not collecting any sensitive. All right. Blah, blah, blah. This limits our ability to suggest relevant content. Yes, of course it does. Users' devices would be intelligent enough to observe patterns in what users are interested in without having to share them with anyone else. For on-device privacy-preserving recommendations, okay, that doesn't require user interaction data to be collected. But what is it? But what I want to know is whether you're like uploading. And I think maybe I just should have looked at this after all. So we've got multiple users. They have some database, which is somehow connected to a row vector. I guess these are like observations of your behavior or whatever. And then we're going to apply the gradient or nabla of V1, whatever LDP is. And so we're going to apply some matrix, which is essentially some kind of derivative, I guess. And we're going to get some stuff back that is this V tilde 1 that has certain indices or grade. Don't know what that means. And that's going to go to a proxy network. And some server, presumably run by Brave, and the server is going to output a new V, I guess, and send it to the users. And this V is somehow different from the enumerated Vs. So maybe this V is visually the same size as these Vs, but maybe somehow these Vs are like anonymized versions of this or whatever. Okay. All right. Initially, each client initializes its own local user embedding XU. So that's what this stuff is some local embedding, user embedding. The client is tasked with continuously processing the incoming item matrix V from the server. So you are going to download something from the server, which is V, from the server, and using it to update the local user embedding and producing a local item matrix gradient update V. So it's the gradient. The client never shares its local user embedding with anyone, but it does produce a local item matrix gradient. The local item matrix update is privatized by the LDP module and shared safely with the proxy. Okay, so privatized and safely, I guess, are doing a lot of work here. Once the training is finished, the client can use its local embedding in conjunction with the latest item matrix received to compute recommendations on device. Okay. Cool. And then what is LDP? All right. Maybe something privacy, distributed something, latent, Dirichlet, local differential privacy for deep learning. Okay, so I'm going to guess LDP refers to local differential privacy. Let's see if we can find the word differential in this announcement. Okay. All right, so I was looking at some other thing that might have been an earlier release from Brave, where it seemed like that you were not really uploading anything, or maybe they said it was like reported with the privacy respecting protocol, and maybe what they mean by privacy respecting is that they've applied some sort of differential privacy stuff to it, and but it does seem like if you're using Brave, then you are essentially training a machine learning model on your data and sending that to Brave. So that seems to be what's going on. Let me check something. Okay. And so I have a chat. Okay, so how does the browser render HTML? That's a good question. Let's see if we can find out maybe where that is. But are you the Subham? Are you the person who originally requested that I look at things like this, like Brave, and do more browser stuff? I'm not sure if I remember the name correctly of who asked that. Okay, so here's the Brave performance predictor. I guess I'm not going to really look at this, just in the interest of time. Brave private CDN. I don't know if private CDN means, like, I don't know what it would mean for, like, I guess a local CDN doesn't really make sense, but maybe Brave has its own CDN that that uses, either maybe it rebrands an existing CDN. Private CDN request helper. Private CDN request helper ensures that the request is made anonymous and reduces boilerplate. Okay, so maybe we're going to make a request to some CDN and anonymize things. Download to string. It's going to take a URL. Download to string callback, auto retry, network change, and then a max body size of 5 megabytes. Private CDN request helper. Okay, so how do we maybe see if we can see anything about private CDN helper? Let's look at the unit test. Okay, so we've got some string inputs and some string outputs. Inputs and outputs must have the same number of elements. Okay, this is not actually super useful. I'm curious about what they're doing to actually make things more private. Private CDN request download to string. I'm gonna set some body size, etc. Request stuff. Clear private request. Oh, sorry, create private request. So we're gonna make a new resource request. And what makes it private? Load do not save cookies. Okay. Load flags allow cache. Although we want to accept the param for this, if we are requesting static URLs which do not support etag, don't send or save cookies. I guess that's the private thing, is not sending cookies. Don't send any identifying information such as language or user agent. Okay. And then we've got the URL loader. Private CDN requests should be simple data reads, so allow retries without fear of repeated operations like we should have with an API. Okay, so it's not going to send cookies, and it's going to remove identifying information such as language or user agent. And it's going to do that by iterating over the private CDN headers and setting them. Okay. I guess my thought here is Brave is making a decision in code about which things have identifying information. That's a little bit tricky because it's essentially an arms race with whoever is using machine learning to fingerprint browsers, right? So it seems like nearly anything you send can be used to track you. I guess it's, somebody who's more up on the security research would know better than I would about how much privacy you can gain by doing that sort of thing. All right. So where are we? Private CDN helper. Okay. Private CDN helper, get instance, remove padding. Okay, I guess we don't need to look at private CDN helper. We have Brave referrals, common in browser, Android Brave referral services. I don't know what referrals are, but maybe some kind of advertising that you can get tokens for by referring people or whatever. Brave rewards, core common browser. Bitflyer attestation contribution credentials database endpoint. Legacy Gemini promotion, publisher recovery report SKU wallet provider, constants and ledger. Do you think this is the ledger code? Might be rewards, maybe. Let's see if this is the main ledger code. I mean, by main ledger code, I know at one point they had like a wallet based on like MetaMask, I think. And now it's built in. I don't know if the wallet is part of this repo, but maybe it is. Is debug, is testing, publisher, banner, callback. This does not look like wallet stuff to me so far. Get balance report, callback. Well, maybe. Contributions, info list, get monthly report, callback. Get all promotions, callback. Unverified publishers, callback. Okay. Maybe it is. We can create, so ledger, we can create an instance, initialize it, create a rewards wallet, which takes a callback and returns void. One-time tip, which takes a double as an amount. I thought money was usually done with integers as opposed to floats. Okay. On unload, on XHR load, get activity info list, get auto contribute enabled. I guess you can automatically contribute to stuff. Claim promotion. You can take a promotion ID and a payload and a callback. Callback returns the result as JSON. Okay. A test promotion. I don't know what a test promotion is. Maybe it's a kind of a promotion you can attest to. Get rewards internal, get publisher info. All right. So this might be the main code, but this is just the header. So let's look at the implementation, ledger.cc. And what are we importing? We're importing the header, the ledger impl, and some media stuff. We're going to look at the ledger impl. Ledger impl, and we've got .h and .cc. Let's look at .cc. Okay, a bunch of Brave reward stuff we're including. This is a giant function that's just going to create the class type, I guess, ledger impl. Yeah. So maybe this is not an implementation. Maybe this is like an interface that other implementations specialize. I don't know. Okay, we've got some templated code. So it looks like this is looking fancier, like fancier C++, which is a sign that we are in the belly of the beast, whatever the metaphor is. Okay, run DB transaction implementation. It'll take a DB transaction pointer and a run DB transaction callback. And ledger client is going to run DB transaction. But this kind of looks like the DB is like a traditional DB, maybe like a local database. What is ledger client? Oh, we've got a wallet somewhere. Okay, so maybe we imported wallet. Yeah, okay, core wallet. And then what was the ledger? What was it called? Ledger client? Yeah, you're going to pass in a ledger client. See if you can find ledger client. That might have been another file. Okay. All right, what else? Ledger client is here. And it's got some callback stuff. Fetch icon, load URL, callback on you. Okay. Ledger client has on reconcile complete. All right. So I guess maybe that's like reconciling with the rest of the distributed database. Load ledger state, load publisher info, on publisher, updated, fave icon stuff, log, set booleans, etc. Run DB transaction. All right. And then there's something that was, what is it? Wallet? Wallet.h, wallet balance. Did I open this successfully or no? Yeah. Okay. Let's look at wallet.h and wallet.cc and wallet balance. Use balance. And we're in the ledger namespace on fetch external wallet balance. So we're going to fetch external wallet balance and then have a callback. All right, what is this? Wallet.cc. Wally BIP39. That is some Bitcoin RFC design document thing. So Wally, it's going to be initialized with a pointer to a ledger implementation. We've got to create. We're going to return. We've got this thing that returns a Mojam rewards wallet pointer. And whether something's been corrupted. Okay. What does this function do? This is just get wallet, I guess. Okay, so get wallet's doing some real work. It's not just returning something. So we're going to get string state, I guess, as JSON and check it's not empty. And then we're going to read from the JSON, which is going to give us something that we're calling value. And we're going to check whether value exists and whether it's a dictionary. And then wallet is going to be a new Mojam rewards wallet. And we're going to look for payment ID. And recovery seed. I don't know what a recovery seed is. Maybe it's like a snapshot. You've got like some random process that generates ID keys or something, and maybe that's like the snapshot of where the random RNG was when we stopped last. I don't know. I'm just making stuff up. But that's possible. And then we got this decoded seed. And what are we going to do with it? We're going to base 64 decode it. Okay, so we saved it in base 64. And then we've got the vector seed. And we're going to assign it to the decoded seed begin and decoded seed end, which was what, a string? Where was it? Yeah. Okay, decoded seed was a string. And then we're going to set the wallet recovery seed to the vector seed and return the wallet as an object. All right. So let's see what else we do with this recovery seed. I guess not much else. Set wallet does some checking with the recovery seed. Mm-hmm. Okay. I don't know. So this does seem to be, this is where I would look, at least initially, for, this looks promising for the main ledger implementation. It's got this Mojam stuff, which is IPC. So maybe it's communicating with the real wallet and ledger over IPC. And this is kind of like the Brave browser's interface to the to a wallet that's running on another process. That's how I will interpret it for now. So here's wallet.h. We just looked at the C file, so we don't need to look at the header anymore. I think we already looked at ledger.cc. Brave Shields. I'll look up what Brave Shields is. Hey, hello, Shandu. Okay. Brave Shields block the stuff that follows you online across every page you visit. So this is like tracker and cross-site cookie blocking, it looks like. Let's look in browser. Ad block component. So this is some kind of interface to the ad block engine, which we're already 2 hours, so I don't want to go too deep into it. But we've got some stuff like should start request, some regex stuff, edit, enable tag, which design pattern. It's going well. How's it going with you? Which design patterns do I like? I think I like all of the design patterns, I guess. I don't know if I have like a favorite one that I'm excited about, but I mean, it's a good question. I guess one thing I deeply believe in is composition over inheritance. I don't know if that counts as a pattern. I don't think it's one of the big four patterns, but for a while, like people were really pushing object-oriented design, and there's a lot of, however, that just tell me the names of the patterns. Yeah, I don't know. I feel like all of the patterns are good. They all have their place. I think that I'm not sure. I don't have a good answer for you about what my favorite patterns are. But if you like patterns, I mean, if you haven't, just definitely check out the Gang of Four pattern book, which I forget what it's called. Thanks, DigitalOcean, but maybe what I really want is like an image. Design patterns. Yeah, these people, I mean, this is kind of like where a lot of the pattern stuff came from. You know what? I'm going to forward this question to ChatGPT. What do I think about AI? What do I think about AI generating code? Is maybe, I guess SE is software engineers. I think that AI is going to get better and better. I think we're not there yet. The code that the AI is going to replace now it's basically operating as like a fancy copy paste thing. It's essentially quoting code that it's seen before, but at least like the free version of ChatGPT and other things I've looked at, the AI doesn't actually understand what's going on in the code. It has no internal model of the way that the code is structured, and so it's just it's like repeating things it's heard before. Yeah, so I think that what's going to happen is that the browsers, not the browsers, but like the editors are going to get better and better at boilerplate, and And the challenging parts, I think, will continue to be challenging. So it's going to lower the barrier of entry for a lot of developers, which means, I guess, economically, developer salaries are probably going to come down in the long run. 5 years, yeah, I think that will be noticeable for sure. Um, but I kind of, where I am now is I kind of feel like what it's going to do is it's going to refocus human creativity in development toward more interesting problems. So I think it's going to eat away kind of like from the outside, the outside of stuff that's like right now mostly being handled by tooling anyway, at least at a big company. But it's going to make that tooling easier, simpler. Static analysis is going to become much, much better. Um, and one thing it might do is like these um, programming languages, maybe like Python or JavaScript, these kind of these programming languages that are focused on like scripting, but don't have a strong, in my opinion, type structure. Those might see some attrition, like people moving to other languages, things like Rust or whatever, because even though the Rust type system is like more stuff you have to think about than something like Python, the AI will make it much easier to think about it, and the tooling will be great. So like things like types will just kind of, you'll get them automatically, and then you just have the benefits of type checking. As opposed to something like in Python or JavaScript, you often have to do your type checking like in unit tests to make sure that the code is really doing what you want. So that's kind of where I see things going. I'm not too worried about AI replacing software engineers in the short run, but certainly in the long run, software engineering I think will look much different than it does now. But I'll ask ChatGPT is what is your favorite? ChatGPT tells me that it always tells me it doesn't have any preferences. Um, well, maybe it won't tell me. But yeah, like for me, like patterns is like what's your favorite Lego brick, I guess. Like the thing about patterns is it's not, you know, knowing which one to use where, I guess, rather than like this pattern is like super cool or whatever. Okay. So we are in Brave Sync. I'm guessing this is going to synchronize stuff, maybe like tabs, history, something about QR code, I guess, for if you have a Brave instance that's signed up for sync, you can maybe generate a QR code to set up sync on another browser, on another instance. So I'm going to ignore that. VPN, based kind of on what I think Firefox does, I'm going to guess VPN is basically they run their own VPN, possibly a rebranded version of an existing VPN. Brave VPN service. Okay. Yeah. So let's see if we can find out. Did I close ChatGPT? Oh man, I have so much to go through. Okay. So let's see if ChatGPT is willing to respond. I'm having some sort of, what was it? Chromium wasn't responding before either. Okay. Yeah, I don't have any preferences. All right. Yeah. The singleton pattern. Okay. All right. Let's get rid of this. Hey now. All right. So I'm going to ignore ChatGPT while I try to close out whatever this is. This is VPN. Yeah, I'm going to look up who, Brave VPN. All right. We've got the singleton. It recommends the singleton pattern, the factory pattern, observer, decorator, and MVC. MVC pattern is good. A lot of these patterns, I guess, like I associate with Java style object-oriented programming. Even when I use, I am not streaming on Twitch. That's true. Right now, I'm not streaming on Twitch. Um, I tend to use a more functional approach. So even in things like C++, I don't go crazy with it, but it's common to pass around function pointers for things or capture things in lambdas, that sort of stuff. So I tend to have like a mixed approach, and so I tend not to do things like have factory patterns, singleton patterns. Um, you There's no avoiding in some cases. Factory patterns, I guess you could consider like a functional variant of that, in which case I guess I do have them. Um, but these are all good. Like, there's so much of development that's about, there are only so many, there's complicated stuff and it's like connected in some sort of web or network. And patterns are about like thinking through common ways of that connectivity and kind of like best practices. So, anyway, that's how I think about them, rather than as like, when I first got started, I thought of them more as like a cookbook. Like I'll use visitor pattern for this, or I'll use like a factory pattern for that. So here's the Brave VPN. The thing I really want to know is what it is. What VPN service? Hmm. Did I close ChatGPT? Close Emacs. There's no way I'm getting to. There's no way I'm like reasonably getting, I think, to all these files. So we'll see. We'll see. See what I can do. All right. Let's see. Let me go back to ChatGPT. Oh, this is AdBlock Rust. Yeah, I'll keep that around. Um, I'm wondering if, okay, so as an AI model, okay. So, I'm going to ask it if it's a rebranded version of an existing VPN service. Okay, it's based on Guardian, which is a subsidiary of the company named Adaptive Mobile Security. The Guardian VPN was acquired by Brave, in March 2021 and rebranded as Brave VPN. The core technology and features of the Guardian VPN were integrated. Okay. Let's just see if it knows anything about security audits. Okay. Is a well-established security solutions provider. All right. So Brave conducted their own security audit of the VPN. Okay, during, I guess, as part of due diligence. It was by a third-party cybersecurity firm to ensure. Okay. Integrity and security of the VPN service. It's worth noting that the audit was conducted before the service was rebranded as Brave VPN, and therefore may not be fully representative of the current state. Okay. So, Brave VPN seems to be, if we believe ChatGPT, which is not always accurate, but maybe we can do a quick search. Brave VPN Guardian. Seems like something that ChatGPT is not likely to hallucinate. Okay. This seems reasonable. So it seems like they've had a third-party security audit, which is good. Okay. What will be the cap? How much people willing to pay when AI tools are widely? What do you mean by? Can you say more? What you mean by cap? All right. So let's get ChatGPT out of the way and try to close out some files here. And I had a request to look at where it renders the HTML. Well, I'll try to look at that at least quickly. But the answer is going to be it's complicated. That's like the hardest rendering HTML. The HTML engine, if I understand correctly, is like the hardest part of the browser. That's why you don't get many browser forks. So Firefox has an HTML rendering engine. I think that is what Gecko is. Chromium has its own rendering engine, and I guess Firefox tried to make a new one in Rust, but that project got canceled. But anyway, my understanding is like that's there's so many edge cases in rendering HTML and like making it compliant with like whatever, just stuff like what did AOL do back in the 1990s, or what did like Microsoft Internet Explorer do in like Windows 95 or whatever. That like backwards compatibility, like that, edge cases, all of that's going to be hard. But as a basic, the basic thing that it will do is it will kind of like render the document in kind of like a as like a plain white document thingy, and then CSS is going to come in and style things. So there will be a whole lot of code to handle all of that. So I'll try to find out where that is and like poke around a little bit, but that's kind of like the heart of what makes a browser really hard. The highest pay someone can get paid in software engineering. I'm gonna guess there's no, even with AI, I would guess there's no upper limit. I would say. I think I would guess maybe maybe you might get like a bimodal the distribution of engineer salaries might become more bimodal. Like you might have like wizardy people at the really top end, and then a whole lot of people who are maybe more reliant on the AI to get their work done, but they cost less to employ. You might see stuff like that, but overall, honestly, I'm not so worried about the software engineering pay. If I were thinking about going into the industry, and I'm alive now and able to use a computer, I'm old enough to use a computer, then I wouldn't worry about it. But if you're like 19 and you have kids, you might think about whether what things will look like by the time your kids are grown up. But I mean, if you get good at software engineering, I think that there will be people continuing to pay a lot for like really outstanding software engineers. Just a guess. Nobody knows this stuff, but almost always people predict much more change than actually comes. Certainly in the short term. That's been what I've noticed about any of these disruptive technologies. Okay, so here's Bravecore base, and we've got process stuff. See if there's anything in process. So we can launch processes, and then we've got what looks like compatibility, maybe with Mac. Okay, so we'll ignore this. Here is the app directory, and we've got things like access code, Brave command IDs, Brave exe, generated resources, main delegate, strings, I guess maybe some, whatever GRD is. I'm guessing maybe these are string like literals. Yeah. And this is going to support things like internationalization. File manager stuff. All right. Welcome strings. This is, I guess, like user interface stuff, but not the sort of stuff like rendering HTML, I'm going to guess. So here's Bravecore common, extensions, importer, licenses, profiler, Brave channel info. I don't know what a channel is. Resource bundle helper, resource bundle. Maybe, I think resource bundles I'm familiar with from Android. Maybe this is ultimately from Chromium. We have a content client, profiler, licenses, importer, and extensions. Okay, so get channel name. That's all we have in this channel thing. Resource bundle helper, initialize resource bundle, and subprocess needs resource bundle. So we're going to bundle up some resources and check, possibly, I guess, pass them to a subprocess. That seems consistent kind of with what's going on in Android. Here's, I guess, components again. Isn't that where I just was? And this has everything. Blocked content, component strings. history clusters. I'm going to look at IPFS just because I feel like I should at least take a quick look at it. Features, Brave IPFS client updater, IPFS constants, cookie store, DNS resolver. I guess you can use IPFS as DNS. Maybe this is just support for browsing IPFS in a web browser. IPFS utils, node info, repo stats, sandbox. Don't know what P3A is. Ports, features. Let's look at features.h. And let's see, Brave browser IPFS. Brave integrates IPFS, the peer-to-peer, blah, blah, first privacy, okay. To minimize its effect on system resources. To use a local IPFS node, that node will be lazily loaded. So here's IPFS features. I don't know. So like, I think you can browse IPFS with a web browser, and that's what this is about. It's like built-in support. So here's their Brave Core V8 directory. So let's see what is in here. Isolate page graph utils. Brave page graph. I want to know about the Brave page graph, I guess. And page graph delegate. So this is all stuff about handling somehow the page graph. What did I just grab? Brave components. Right. So here's components. Was it page graph or was there Brave in front of it? Here's P, page info. Brave page graph common. Features, build flags. But what does it do? That's what I want to know. Add page graph core. That's just for listing features. What are we going to depend on? Let's look at the build file. I don't know why GitHub is slowly crawling. Maybe a web search. Seems to be my internet, or at least on this VM. Okay, so while that's loading, I'll look at some other. So tools is like POSIX, Android, Mac. So I'll ignore that. That's like customization to specific platforms. UI, Brave ads, and web UI resources. What is web UI resources? Oof. Here's services. Yes, tracked and CPP. I'll close that out though. Render thread observer. What is a thread observer going to do? It's going to have some Mojo interfaces and do some configuration stuff. So I guess the thread observer is render thread observer. So I guess there's some render thread and maybe it speaks Mojo to the rest of the stuff. So we're going to like, I guess the main UI is going to be the thing that like sets up windows or whatever. And then tasks that take a while, we're going to pass to another thread, and maybe that's what the render thread is, and it's going to be like a worker thread for rendering things. That's just a guess. So system request handler is the thing that's in services network CPP. That's system requests. Tracked is empty except for a build file or for a sources.gni file. So we'll ignore that. Web resources. Things like fonts, CSS, BR elements, page specific. Okay. So mainly I'm just trying to close out a bunch of stuff at this point. Brave content renderer client. Okay. This is under renderer. Render thread started. So we do have a render thread. We're going to render a frame. Okay. Run scripts at document start. We'll evaluate service worker on thread. Okay. Okay. Page specific. I'm not sure what this means. We've got bookmarks, downloads. Maybe it means like the bookmarks page, the downloads page, the extensions page. I'll assume that's what it means for now. Here's the Brave page graph, the build file. And I'm not sure what it's up to. I was looking at page graph just to see what it is. Okay, it's a research project. PageGraph is a research project developed by Brave to instrument the Brave browser, Blink, and V8 to allow for complete attribution of document modifications, network requests, script execution, and privacy-relevant web API accesses. PageGraph crawl tools and scripts which automate enabling PageGraph in Brave. Currently does the following: tracking the execution and results of all script execution and how the script got on the page, tracking most resource requests, tracking all DOM node creations, deletions. So it sounds like this is not enabled by default. PageGraph is the next production-ish version of AdGraph, an earlier system for representing page execution as a directed graph. So I guess AdGraph is probably a Brave thing. The graph-based approach to ad and tracker blocking. So I guess they're going to try to block ads by building this graph. So that sounds like it might be slow. We evaluated AdGraph on the Alexa top 10K websites and found that it is highly accurate, able to replicate the labels of human-generated filter with 95.33% accuracy. And okay. It's actually faster than stock Chromium on 42% of websites and AdBlock Plus on 78% of websites. Okay, so it sounds like they think that there's a speed boost here from this AdBlock stuff, but that's a research paper. So sometimes with a research paper, you have like a smaller implementation that seems to perform really well, and then you add more features to flesh out the implementation, and then all of a sudden it doesn't perform well. So who knows? They've replaced whatever the ad graph was with whatever page graph is. So I guess they decided at some point that ad graph wasn't doing what they wanted it to do. All right, so here's some SKUs. I'm just curious what they have in here. So we're just going to load SKUs. I was curious to see if they had actual SKUs of some sort. And what else? Brave Wallet dependencies. We'll ignore that. Here's just Brave Core as a root. And then here is AdBlock Rust. And we are just going to ignore AdBlock Rust. I think let's look at the engine in the lib and the optimizer and the regex manager. That'll be my definition of ignore, I guess. We've got the engine has a blocker and a cosmetic cache. I don't know what it means to be cosmetic. Main ad blocking engine that allows efficient querying of resources to block. Okay. So the engine implementation, the new thing creates a new ad blocking engine. It should generally only be used with deserialization if they don't have rules. You can, from rules, I guess, load rules in a single format. Serialize raw. Serializes the engine into a binary format so it can be quickly reloaded. Okay. Check network URLs. All right. Get CSP directives. Returns a string containing additional CSP directives. We can check if a filter already exists, that sort of thing. Use resources. Sets this engine's resources to be only the ones provided by in resources. Okay. We don't really have time to look at this. I guess this Rust thing, tests are in the same file. All right, here's lib, and there's not much to lib. It's got some tests. And maybe these are exported modules. Own modules. Currently, everything is exposed. We'll need to limit. I feel like once you expose something, it's harder to limit. But I guess it's they can work it out. Optimizers. We have a function called optimize. It's going to fuse net filters together by applying optimizations sequentially. So we take a vector of net filters and we return a vector of net filters, and we're going to somehow fuse them together. We're going to combine them so that they're doing less work. We've got what appears to be commented out code. Apply optimization. Okay. All right, so you're going to load in some, it seems like you're going to load in some filters, and it's going to and maybe like deduplicate your filters. Like you might have filters that are doing more or less the same thing, and somehow it's going to iterate over your filters and like compile them or compactify them, because it has, I guess, a global view of all of the things you're trying to filter. And then they're going to try to do that and do the filtering as quickly as they can. And here's a regex manager file. Unsafe implementation sent for regex manager. Const network filter could technically leak across threads through the regex entry ::ID, but it's disguised as a unique identifier and not intended to be dereferenced. Okay. I don't know what that means from a like security or performance point of view. We've got a regex entry. You're just going to have a regex when it was last used and usage count. Okay, some random state and a hash map that takes three things: a network filter, a regex entry, and a random state. We have make regexp, which is going to take a network filter and compile a regex for it. Okay, so that's at least a quick look at the ad blocking Rust stuff, which seems cool. I would love to read more Rust code. I've thought about looking at the code for uBlock origin, which seems Brave says that they've based their blocking code on uBlock, so maybe that's a place to learn about how ad blocking works. And before I go, we're now 2 hours and 30 minutes in. Before I go, I said I would take a look at least a quick look, a very cursory look at the HTML rendering code. I don't know where that is, but let's see if we can find it. And I'm going to guess it's in Chromium source. Components, Chrome, content, maybe under Chrome, Google APIs, media, net, sandbox services. Maybe it's the rendering service. I don't think it's V8. V8 is JavaScript. And there will be something that can render bare HTML, it seems like. Okay. So under Chrome, maybe renderer. Maybe I can just look up Chromium HTML renderer. It's Blink. Actually, we saw this before. Blink is the name of the rendering engine used by Chromium and particularly refers to the code living under third-party Blink. So it's not even in Chromium. It's not even in the main code base. It's a third-party thing. Here's the Blink browser engine. It's developed as part of Chromium, right? It's a fork of web core component of WebKit, which was originally a fork of the KHTML and KJS libraries from KDE. It has the following three components: DOM, HTML DOM, and CSS rendering engines, a web IDL pipeline, and the Skia graphics engine and the V8 JavaScript engine. Web IDL is interface description language, I guess, for web. All right, so Blink is going to be in here. We've got core extensions, modules, platforms. We've got these build.gn files that we saw in Brave and bindings. I'm guessing core. Here's DOM. Geometry, HTML. Painting is going to be a part of it for sure. SVG will be SVG support. Style might be CSS. And then XML. HTML is a variant or derivative of XML. So we've got things like XML XPath evaluator. So there'll be some path in the XML document, and that will that is something we can use to decide what to do with HTML documents or whatever. You can view HTML trees. Yeah, there's just so much here that this would really be its own thing. Core style has things like basic shapes, computed style. Here's HTML. We've got like anchor elements, blocking attribute, build file, document, all name collection, HTML area element. Let's look at area element. HTML document. So this is an image element, is default point area, physical offset layout object. Yeah, so anyway, this is where the code is. Um, it would it would be its own thing to really look at it. Um, I think the original comment that kicked me off to look at Brave included the question of um, how the browser UI stuff worked, and there were like three questions or whatever in there, and so I will look at that. I'll look at how the browser UI works. I don't know when I will look at it, just because we've got so much stuff coming up. But a related thing that I'm planning to look at soon is the code for Flutter, the Google mobile app development framework, and React, the Facebook, I think mainly web development framework. And so both of those are going to, I think, do a similar thing to how browsers render HTML. So whereas I mentioned however many minutes ago that HTML rendering is in a sense one of the hardest parts of building a browser. There's just so much like history and edge cases in it. The newer things like React and Flutter, I expect that they'll be doing more or less the same sort of stuff, but without more on their own terms. So they're like several generations after things like KHTML that Chromium was based on, or Gecko that I think Firefox is based on. So I think that will be good. If you're interested in how browsers render HTML, I think it might be good to tune in to the streams where I look at Flutter and where I look at React. And that will, and maybe also look at some of the stuff I did with the game engines. Those are all kind of similar in spirit. We're going to draw things on screen, and we've got to take something that describes like a layout kind of object, typically in XML or some variant of XML, and we're gonna translate into that into a bunch of stuff that's rendered on screens. And so if you kind of come with that spirit and with that context, and by the time we eventually look at browser HTML engines, I think you'll notice and recognize a bunch of the patterns. But the kind of fiddly bits where you have to build in compatibility with various different browsers and operating systems over the last, 30, 40 years that we've had mainstream web browsers. That stuff, it'll be easier to just kind of like squint your eyes and ignore if you have a better sense of what of what's really of what it's really trying to do, if it didn't have to be so concerned about all the fiddly bits. So I'll leave it there. At any rate, so that's it for me for the Brave browser. Sorry about the connectivity issues. I'm not sure what I can do. I'll see what I can do. If it's maybe I'm just overloading the pipe by doing these long videos or whatever, or maybe there's something outside of my control that's going on. But I'll see what I can do to try to make that not happen again. And but let's recap, I guess, by saying what we've learned on this very long Brave video. We explored a bunch of stuff like the various Brave feature sets, looked at what their value proposition was a little bit, kind of like as we came along different features, and I wasn't sure what they were supposed to be doing, and so it seems like they, what did we look at? We looked at the on-device like federated learning stuff. They've got like a VPN service. and they've they're like it seems that they're injecting ads and kind of keeping track of ads in a way that's trying to preserve privacy. Um, and we also looked at I was trying to look at things with an eye toward given that they're extending Chromium, might they be doing anything that would cause it to have different performance characteristics than Chromium? We saw some stuff about the singleton pattern in the Chromium developers warning against using singletons. But again, it seems like the Brave singleton use is at least in line with how of what's going on in the Chromium code base. What else? Did we learn anything else super exciting? I think we may have found where their ledger and wallet code is. At least we found a good entry point for if you poke around there and like find the sorts of terminology they're using in those files, you'll be in a better place to find out exactly where all of the ledger stuff is. So it is a really cool project. I haven't personally used it, and it's huge, which is why this video is so long. So that's Brave browser for now. If you're coming away from this feeling like we didn't really get to the heart of everything, or we didn't fully explore everything, that's totally true. We for all of this stuff, we're taking a look, doing something else for a bit, coming back to take a look, and so we're gonna keep coming back to browsers and like going, do some stuff on browsers, do some stuff on the kernel, do some stuff closer to like rendering and hardware, do some fun stuff like games, and we're just going to kind of move around like that. And in this process, the idea is that next time we come back to browsers, maybe some of the stuff we learned in the other videos is going to give us a new appreciation for what we're seeing in a context we've seen a little bit before. So that's that. That's Brave. Hopefully you'll have a good weekend, and I'll see you on Monday. You can check out my schedule on which is up on YouTube, and then on Friday of next week, I'll do a regular video during the morning, which will be on an open source Linux game called I forget exactly what it's called, like Linux Kart Racer or something, like a kart racing game. And then in the afternoon, I'm going to do a stream with my brother, I think probably on Twitch. That's just us playing a video game, a non-open source video game called Disco Elysium. And as I mentioned in another stream, the idea there is that he and I have been contemplating building some sort of video game together just for fun. And this is maybe part of the research, since I'm not as familiar with the gaming world as he is. So I can get a better sense of like what modern games look like from a, as somebody who's playing it. Like, what are the cinematic qualities? How are the stories written? How are the controls from a UI perspective? Kind of those sorts of things that you can only ever really figure out by actually playing through a game and having fun with it. So that's what's coming up. Thank you so much for watching. And that's all for me. Thanks. Bye.